Why do functional programmers focus so much on time? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So we talked about the different sources of complexity in software, and one of the major sources of complexity has to do with different possible histories. So when you have, let's say, two threads running on a single CPU, this is a very simple case. These threads don't actually run at the same time. There's only room in the CPU for one operation to happen at a time. And so what we talk about is that the operations in the threads can interleave, meaning the thread scheduler is going to let one of them run a little bit, one thread, and then it's going to switch to the other thread and let that one run a little bit and then switch back and forth between them. And you don't know when that switch is going to happen. So every time you run it, it's probably going to be different. And so where the complexity comes from is that you don't know what the next instruction is that's going to be executed. It could be the one from this thread, it could be the next one from this thread, and then of course if you have a lot of threads, if the threads run for a really long time, that if you had to calculate how many possible ways could this run, then you get this really big number because it's a combinatorial explosion. Just as an example, if you have two threads, very, very small case, two threads, and each thread has 12 actions that it runs, the number of interleavings is already at 1,000,000, right? And so 12 instructions is a very short program. It does almost nothing. So our programs that we write in higher level languages are going to have so many interleavings, like millions, billions, trillions of possible interleavings. It's really hard to tell what is going to happen next. And there's no controlling it. Once you let the cat out of the bag with threads, that's just the problem you face. There's nothing you can do to push that back into the box, right? What you can do is start to manage it, and that's manage it more cognitively by reducing that number of possible histories using some kind of concurrency things. Now, I've been talking about threads as an example, but it happens with other things too. It's not just about threads. So JavaScript famously only has one thread, and the same problems happen to it because once you introduce async callbacks, you now have this same problem, right? Just imagine you make two AJAX requests, one after the other. Which one comes back first? You can't know. There's no way to know. There's no way to control it. The callback or the promise or whatever for those AJAX requests are going to get called in different orders, different depending on how long those requests took to process. And so you're just introducing this same problem of I don't know what's going to happen next. And I have to think about all the possible ways that it could happen next. There's 4 actions that could happen after this one, and in fact it also has this same property that it's a combinatorial explosion. Now, to unify all these ideas of threads, or first, let me take a step back. The things that do have this same property of exploding number of possible things next are threads, asynchronous operations. So you think of a callback chain, any kind of promise, like a linear promise chain, or async, nested callbacks. All of those are creating timelines. Two processes running on the same machine, if they communicate or share anything, you're going to have this problem. And that includes the web server talking to the database, right? And anytime you have multiple machines in your system, so that's like every web application that uses any JavaScript, right? So you have, or I mean, even if you don't use JavaScript, you have this problem because the browser is still handling stuff for you. But you have the web server and then a whole bunch of clients open at the same time on the web page. And even if they're not doing JavaScript, you still have the user clicking different links or, doing posts, posting forms at different times that you can't control. Like on the server, you don't know what the next request that's going to come in is. Is it for this user, for that user? It's the same problem. So this is the world we live in today. And it's a world where we have to start thinking about time. Because, time, I'm talking about Einsteinian relativity, right? You have a web page open, I have a web page open, the same page, right? And I click a button at the same time on the wall clock as you click the button. But to me, to my browser, it looks like I clicked it first because I clicked it before I got the message that your thing was clicked. And you clicked yours before you got the message that I had clicked it. Right? So you have this problem of it looks like I was first, and to you it looks like you was first. Same as like in relativity, if you're looking at two different supernovas at the same time, which one happened first? Well, it depends on where you are in space relative to those two supernovas. Okay, so this is a problem that we are faced with all the time now. It adds a huge amount of complexity to our software. It's like platform tax in complexity. You're on the web, boom, you got this problem. Which is probably why functional programming is getting more popular now. We're realizing that the languages we used before were based on this single threading model, and they just don't have what it takes. They don't have the tools built in to deal with this. Some of them do to a greater or lesser extent. I'm not saying that you can't use like a procedural language like on the web. I'm just saying that functional programming is getting popular because it has been thinking about these problems. It has been asking these questions for a long time. And not in a simplistic way, which, a lot of languages, let's say like C, the main way that you would do this to handle concurrency is with locks. But locks just don't work across machines. There's no distributed lock that is reliable, that works well, that you would want to use in a system like this. They don't scale that well. So we need better tools. And the whole idea in functional programming is making time a first-class concept. It's not a first-class value, like we talk about functions are first-class values, but it's a first-class concept. We're thinking about time. When I make an AJAX request, I'm thinking, is this happening before or after this other thing, right? Does the order matter? Does it matter what the wall clock is when this thing happens? Does it matter what order the things get to the server in? And if it does matter, well, then you need to deploy a lot of tools to make sure it happens at the right time. If it doesn't matter, or if you can make it not matter, all the better, because it's just one less thing you have to worry about. So in functional programming, what we do is we do this kind of analysis. We talk about time. We figure out what things matter when they happen, if the order is important, if it matters how many times the thing is run, and we deploy tools that functional programmers have in their toolbox. Some of those tools, I'll just quickly talk about them, is making something transactional. So you have a, say, mutable state. you want a read and a write to be a transaction, so that you always see a consistent view of that state. Well, you can do that in functional programming. You have a mutable thing with transactional semantics for updates. You can make an action idempotent. If you only want to send that email once, but you're afraid that your message to the email send will get sent twice, then on the email server, you can have it be idempotent, meaning it somehow remembers that, I already sent that, so I'm not going to send it again. Okay. And that can be as simple as having a hash map of, the last 24 hours of IDs of emails that got sent, right? So you can guarantee that you won't send it a second time. If it's in that list, it's already been sent. Now, I want to talk just a little bit about the analysis that can happen. So let's imagine you have two timelines. So let's get visual, right? We have two timelines, and there's certain things we can look at. So one is that if the two things don't share any resources, let's call them, so no messages get passed between them, if they don't have any mutable state that they are both reading and writing to, if there isn't some queue that they're both using, something like that, if we can eliminate all of those shared things, then the two things, the order doesn't matter, right? They're totally independent. It's like if you can give someone a task that they don't need to talk to anybody, they don't need to wait for anything from anybody, they're not sharing any tools with anybody, they can just run and do it at their own pace. They don't have to coordinate with anybody, and the order that they do stuff in, meaning compared to someone else's order, it doesn't matter, right? It's one way to scale up, like digging a ditch, is not only do you need more people digging the ditch, but you need more shovels, right? And if people have to share shovels, then they're going to have to coordinate a lot. But if they don't have to share shovels, then they can just work independently, as long as they're not digging in exactly the same spot. All right, so that's one analysis you can do. Another thing you can do is so that's kind of like a vertical cut between the two timelines if we were looking at them going down like this. Another thing you can do is a horizontal cut. So you can do something where in JavaScript you would use a promise.all, right? So you're making sure that everything above this line is done before we continue on, right? And so if the stuff above the line, you can do the same analysis. None of that stuff shares. None of the timelines above the line share anything. But below this line, now we can do a separate analysis because it's cut. We don't have to worry about that. All of this is going to be done before we start the rest. And so that's just another way of like reducing the number of histories that you have to keep in your head, right? So you can now answer the question, what's the next thing that's going to happen? Well, they're all going to wait here. All these timelines are going to wait here until they're all done, and then the next thing that's going to happen is this, right? It just makes it much easier to reason about. Another thing we can do, and this is the standard way of explaining what functional programming is, one thing we could do is just eliminate the action. If it's something that depends on time or ordering or anything, just replace it with something like a function, a pure function, a calculation that does not depend on time, right? Now, here's an interesting thing. You can look at a calculation, a pure function, as a timeline that shares nothing with anything else. It has no shared stuff. So it's the same, it is an action, but it just doesn't share anything. And if it doesn't share anything, we've already talked about that it doesn't matter. It doesn't matter at what order it happens in relative to something else. The interleavings all give you the same answer. Okay, so those are three things that we can do. One, eliminate actions, replace them with pure functions, with calculations, with stuff that simply just doesn't share anything. Two, we can isolate two timelines to ensure that they don't share anything, and then we can stop worrying about what order they have it in. And three is to do a horizontal cut, and you say like, well, we don't have to worry when we're analyzing the stuff below the line. We don't have to worry about the stuff above the line. Now, here's another one that I'm doing this off the top of my head. I just remembered it. You can do something like transactions, right? So that's saying if I have two actions in each timeline A has 1 and 2, and timeline B has 1 and 2. There's actually 6 ways those things can interleave, right? So all of A could happen before all of B, or the A1 could happen and then B1 happen, etc. There's all these different ways, and they could give you different answers. Imagine A1 is read a value, and then A2 is add 10 to it, right? So you're reading and then adding. You could miss because the read of the B happens before the write of the A, and then you've forgotten that second thing. So one thing you can do is put transactions around that, right? And so you're guaranteeing that some of those interleavings are not possible. So all the A's could happen before all the B's, or all the B's could happen before all the A's, but you won't have the thing where A starts and then B starts before A is finished, right? So you're eliminating these bad orderings. And so you're eliminating histories. It just becomes a little bit easier to reason about. You might get different answers because A and B are happening in different orders. You're not guaranteeing that. But you are eliminating some of them. And this is just a tool to use when you're working, because sometimes the order doesn't matter. That's another thing. So you can use operations, replace these actions with operations where the order doesn't matter, right? So if you're counting a bunch of things, the order that the counts happen in shouldn't matter, right? Because by the end, when all of them are in, then you'll have the same answer. Addition, it doesn't matter what order stuff happens in, as long as you wait till the end, right? So this is called eventual consistency. Right, so I'm going to leave it there. The main idea is that functional programmers think about time as a primary idea, and they divide the world into things that depend on time and the things that don't depend on time. And they want more stuff in the places that don't depend on time. Stuff that depends on time requires a lot more work, a lot more thinking, and it is a lot more error prone. All right, my name is Eric Normand. This has been a thought on functional programming. Please follow me on Twitter. I love to tweet out ideas about functional programming. If you're into that, I'm at Eric Normand. You can also reach me via email at eric@lispcast.com. I love to get into discussions. So ask me your questions, tell me your thoughts, what are you working on, that kind of thing. All right, see you later. Bye.